So I'm here today to talk to you about how stellar death shapes us. And to sort of understand how I got to this point, I'd like to tell you a bit of my origin story. So the first person that really got me interested in astronomy was my grandfather, which you can see here in the upper left. And he would take me and my cousins out at every opportunity to go stargazing. And he'd point out the different constellations and teach us the Roman and Greek mythology behind it. And it really embedded a passion in me to look up whenever I could and enjoy the night sky. So when my grandfather passed away suddenly, it was a very tragic event for our family. The last time he was in the hospital was getting malaria during World War II. So it came as quite a shock. And at that point, I actually took a serious reassessment of my life. At that time, I was hoping to become a professional boxer. So I actually shifted gears, and I decided maybe I should honor my grandfather's memory by pursuing education in what I love, which was astronomy. So I went through the traditional career route. I went to college, I got a degree in physics, and then I started attending graduate school to get a PhD in physics. And while I was in graduate school, my uncle Stan, seen here with his son Kyle, suddenly passed away from the H1N1 epidemic that struck our country. And again, this was a very sudden and tragic event for our family. And it spun me into a very dark depression. And the only things that really pulled me out of this depression were the birth of my first son, Isaac, and also my study into the death of stars, because my studies really revealed something that sort of shaped my view on human mortality, that the story doesn't necessarily end at death. So to talk about the death of stars, just like to make sense of the death of a loved one, it's important to understand how they lived. So a star like our sun is a fairly regular star, which is good because they're long-lived and allow for things like life to evolve. And our star is undergoing a constant fight against gravity that wants to collapse it. But in that gravitational pressure, it creates the conditions necessary for hydrogen to fuse. And when this fusion occurs, it releases a vast amount of energy, which actually props the star up from falling in on itself. But just like the fuel in your tank, eventually this fuel runs out. And when this fuel runs out, hydrogen will start to fuse around the core of the star, and this will cause the star to begin to puff up into a phase of existence called a red giant phase. And it will puff up further and further, and eventually our sun will actually envelop the Earth and possibly even Mars. But the remaining fuel it has to fuse heavier elements is very limited because it's a small star. And it will rapidly run out of this fuel, and these outer layers will just puff away. And what will be left in the middle is just a burning ember of what it was, which we call a white dwarf star. Two of these systems are right here. They're planetary nebula, and at the center you can see a very faint white star, and you see this beautiful death shroud that's around. And this is important because when a star like ours is going through its death thralls, it can fuse heavier elements. It can fuse some carbon, oxygen, nitrogen, and a touch of sulfur. But it really needs this expulsion to enrich the surrounding material with heavier elements. And two of these abundant elements, hydrogen and oxygen, in this shroud of gas, when this gas cools sufficiently, will actually form water vapor, which is a key ingredient for life. Now, The purple elements we see here in the periodic table were mainly given to us by the Big Bang itself. And the elements in green are showing you the elements that can be fused in a star's life. Most of these, above oxygen, are actually fused in stars that are much more massive than our sun. But for all the elements we see in blue here, we really need a significant amount of energy to create these, and this just doesn't happen during the lifetime of any star. When a massive star runs out of fuel, it will fuse heavier elements till it fuses up to iron, which will begin to build up in the core like ash. And when it reaches a critical density, it will collapse and then rebound and start to drive a shock into the infalling stellar material. And the core will again recollapse into a neutron star or a black hole, which will create a very enormous stream of neutrinos, which actually re-energize the shock to rip apart the star in what we call a supernova explosion. And this is really the source of energy to fuse all of those heavier elements, because once you get to iron, you get no more energy out of the fusion process. So this explosion is the fuel is really the reservoir of energy that's needed to fuse all of those heavier elements. And when the light of radioactive decay fades in these supernova, it exposes a beautiful object which we call a supernova remnant. And in the core of this remnant, we can actually see the chemically enriched guts from that explosion being repopulated into the surrounding material, just like the case of the planetary nebula, which is crucial for subsequent generations of stars and planets that will develop. And in the blue we see around the outside is actually the blast wave from the explosion that can propagate for thousands of years. Now this is important because it leads us to the next stage in our story. Here we have two nebulae, which are actually stellar nurseries. Now, in these dark clouds of gas and dust are the beginnings of new stars that are forming. But contrary to what you might actually expect, you need very cold environments for new stars to form. But it just needs one more ingredient. And that ingredient is actually the shock wave from these supernova remnants, which can careen into these clouds and cause them to fragment. Some of these parcels of gas will actually collapse and form new star systems, one of which we can see here in infrared. Now, this is special because we're really looking at a baby picture of a new solar system. In the center, we see a creation of a new star, but even more interestingly, if we look at this dark band of gas and dust, we can see this black band being carved out. And the reason for that is the birth of a new planet that's actually sweeping up debris as it orbits its new sun. So these supernova remnants are actually crucial for sparking new generations of star and planet development. Now, a couple of elements I neglected, besides the man-made elements in gray, are the elements in red. Now, these elements are not formed in any stellar process. They're actually formed from interactions with what are called cosmic rays. And again, we're led to the story of supernova remnants. In the shock waves of these remnants, we get very compressed magnetic fields, and charged particles can actually go through and back through the shock multiple times, picking up energy until eventually they have enough energy that they escape. And we call those escaping charged particles cosmic rays. Now, this is important because these cosmic rays can actually interact with molecules in our atmosphere, and when they do, you'll get a collision which will create a particle shower. This is not unlike what we actually see in particle colliders like the Large Hadron Collider in CERN. And these particles will go all the way down to the surface of Earth, and sometimes they might interact with genetic material of a living organism. When they interact with, say, a strand of DNA, it can break the DNA apart. And when the DNA repairs itself, mistakes are inevitably made. And we call these mistakes mutations. And these mutations are important because they're the catalyst for evolution. So the death of stars are important for many reasons. For populating our periodic table, to creating new solar systems, and possibly even to the evolution of us. So, to leave you with some parting thoughts, here in the middle is my son Isaac, and to the right, his brother Alexander, and to the left is the grandson of my Uncle Stan, the son of his son Kyle. And just like stars, death isn't the end of the story. So I'd like to challenge you all to shift your perspective on death, to not think of it as some horrible end, but rather a beginning of a new existence, an existence which has the power to shape and enhance the generations that follow. Thank you.